So we're given isopentane and we're asked to synthesize 4-bromo-3-methyl-pentane nitrile. Now the first thing I notice is the similarity in the shape between the reactant and final product. We have 5 carbons here, and if we count our carbons, 1, 2, 3, 4, 5 carbons here. But we can't ignore the nitrile group, so that adds an extra carbon. So how do I go from a 5-carbon alkane to a 6-carbon alkane with 2 functional moieties? So we know alkanes are limited in their versatility because we can carry out a free radical substitution, but then from there on, the question is, what do we do? So let's imagine we carry out a free radical substitution with Br2, with bromine. In that case, the bromine will selectively add to the tertiary position. Remember, the rate of formation of that is close to 1,600 times more than any primary product. Now, under the right conditions, this bromine can leave the compound and we can eliminate it with a strong base. And that forms an alkene, which is way more versatile. Now, if you take a look at our product, the nitrile is terminal. To form the nitrile, we need to carry out an SN2 type reaction with the cyanide anion as the nucleophile. So in some way, we need to prepare this alkene such that we add a bromine directly adjacent to it and a nitrile extending off the alkene, or the former alkene. That's where NBS and alcohol reactions come in. If we react this with N-bromosuccinimide, we can form the bromine directly adjacent. And after that, with the synthesis of an alcohol from this alkene, we can carry out an SN2 reaction. So let's see if this works. So we said we can carry out a free radical substitution with our isopentane. So to this I can add Br2, dichloromethane as the solvent and light radiation. And that will selectively add the bromine to the tertiary position. So with bromine as our leaving group, we can form an alkene through an E2 reaction. Though it's very important to form the Hofmann product and not the Zaitsev alkene. If we form the Zaitsev alkene, we can't carry out a substitution reaction that puts the nitrile group primary. If we carry out an elimination reaction that gives us the Zaitsev product, the nitrile would be secondary. So we need to use a base that is specifically tailored to form the Hofmann product. A bulky base would work. Bromide anion is expelled from the reaction, and we form the Hofmann alkene. Other bulky bases would work. Isopropoxide would work, or even LDA. So now that I have my alkene, I need to somehow conserve it and add a bromine that's directly adjacent to the alkene right here. To do that, I react this compound with NBS. Trace hydrobromic acid, dichloromethane as the solvent, H-mu. And although there are multiple products, we're looking for this one. And now we're almost there. We have the precursor to our final product. We know the nitrile is primary, so we need to carry out an SN2 type reaction. One option is to carry out an anti-Markovnikov bromination. That generates the bromine leaving group, which we can then react with sodium cyanide. But an even better leaving group is the tosylate ion. So we need to carry out tosylate ester synthesis and then react that with sodium cyanide. And that should give us our primary nitrile group. So we take compound 1 and do hydroboration to form the alcohol. So the alcohol is primary and the rest of the compound is the same. Now it's this primary alcohol that has the capability of attacking tosyl chloride. And with the help of pyridine, we can form the tosylate ester, which is then very susceptible to nucleophilic attack. So let's take our primary alcohol and react it with tosyl chloride in pyridine. And that gives us our tosylate ester, which is abbreviated OTS. Now the last step is to take the tosylate ester and react it with the salt of this nucleophile, sodium cyanide, which can act as a nucleophile, attack this carbon, and expel the tosylate ion, which is a very good leaving group. So we take our tosylate ester and carry out an SN2 reaction with sodium cyanide. And the solvent for an SN2 reaction must be polar aprotic, so I'll use acetonitrile in this case.